As a part of UI Assist project, we have 6 different test beds. Here at IIT Kanpur, we are building a smart distribution test bed, and it is fully reconfigurable. So when we say it is reconfigurable, it means that we can emulate both overhead as well as cable distribution systems. Many of these components that are used in this test bed are built by our graduate students. Before we take a look at the actual distribution system, let's take a look at the blueprint of the test bed. It consists of sources, line emulators, loads. So the loads will represent the renewable powered homes or non-renewable power homes or other establishment. So this test bed is capable of performing HIL simulation using RTDS, power amplifier and fiber optics cable. So if we go to the sources, we have two types of sources that are available. So if we want an ideal source, then we can use a grid emulator. If we want a more realistic condition, we have a 3-phase transformer that can also supply the system. So this 3-phase transformer is a little bit special in sense that it is a 5-wire system where R, Y, B, neutral and ground are there. So neutral and ground are not connected. We may short it to represent an ideal system or short it through an impedance to represent a more realistic condition that is suitable for India. So if we look at the distribution system emulator, it consists of different levels. So the top level is phase A, next is phase B, next is phase C. All these racks are interconnected to each other. So line modules can be placed in each one of these racks and interconnected, and they can be interconnected to represent a longer line. The load part will be on the bottom of the rack. So like I mentioned that many of these components are developed by our students. For example, this fiber optics communication module for PHIL simulation, power amplifier and home emulation etc. are developed by our students. As we saw, there are two sources. One is a transformer which is outside this building and the second one is a grid emulator. So this grid emulator is a 30 kVA grid emulator, and both these sources are connected to the distribution system test bed which is housed inside this glass enclosure. So this is the main distribution grid test bed. It is housed inside that glass enclosure that we saw. So this as you can see that there are racks which will house the line and load modules of the distribution grid. The sources are outside this glass enclosure and they are connected to this rack. And in this particular case, we are performing an experiment of emulating a distribution overhead distribution grid. So this will be phase A, phase B and phase C, and all the loads, that is home loads, will be placed on the bottom of this rack. And in order to carry out this experiment, we will be required to take some waveforms and measurements. So all these measuring devices will be placed on the top of this rack. This is the line emulator. So it represents a distribution line. We have two such boxes, one to represent a overhead distribution system and another to represent a cable distribution system. So this is the input to the line and this is the output from the line. So many such boxes can be connected to represent a longer line. So this box can represent a 60 meter line, a 120 meter line or a 180 meter line. So if we short these 2 points, then it will represent a 60 meter line. If we short these two, it will represent a 120 meter line, and if we short these 2 points, then it will represent a 180 meter line. So by connecting these boxes, we can represent any distribution line in the system. In this test bed, we implement the load in 3 ways. One is a dumb RL load, which was made by our students, and then we can also use an electronic load, and we also have a home emulator, renewable home emulator with solar emulation. Let's ask Bimla to explain it further.
Here is a renewable home emulator. It has three parts. First one is a solar emulator which emulates a solar panel. Second one is an inverter. We are using a semicron module to implement this inverter, and its control is developed in DSP by our students. Third one is a transformer which will be connected to the smart grid testbed at point of common coupling.
Goes between the RTDS and the smart distribution system. It is developed by our students. This power amplifier communicates with the RTDS system using these control cards. These cards are fiber optics communication and control card. So there are two cards. One is placed close to the RTDS and it communicates with the RTDS directly, and then the information is exchanged using this fiber optics cable with another card which is placed close to the power amplifier, and this control card communicates the reference signal from the RTDS with the power amplifier. In the end, let's take a look at our real-time simulation capability. Anju can explain it more.
We have three different real-time digital simulators in our lab. This is Typhoon, HIL, this is hardware in loop simulator, it's a RTDS, and the third one is Opal-RT. We can use these simulators for testing various control and protection algorithms using HIL simulation. Few of our students have also developed a test bed to test the cyber security algorithm on these simulators. We can also interface these PMUs, these real-time digital simulator with the PMUs and PDCs and fault recorders to test the various algorithms related to protection and cyber security.